So January 2018 paper 2. This is according to the old syllabus, because the new syllabus, it is WCH12, and the old syllabus, that is WCH02. But you will practice even the old and the new, both of them, to have a variety of the questions. In the first question, which is a polar molecule? So a molecule for which a dipole moment is 0, overall the cancel out each other, the moment cancel out each other, that is a non-polar. If it does not cancel out, then it will be a polar. So basically, symmetrical molecule, that the molecule is having a symmetry, so then it will be a non-polar. If it does not have a symmetry, then it will be polar. So in BeCl2, this will have a linear structure, and linear structure have symmetry. That's why it will be non-polar. BeCl3, BCl3, boron trichloride. In boron trichloride also there's a symmetry in the structure. Then again it will be a non-polar. CCl4, carbon tetrachloride, tetrahedral structure will be there. One will be in, one will be out, and two of them are in the same plane. So again, there's a symmetry in the structure, then it will be a non-polar. But what about nitrogen trichloride? When we draw the structure of nitrogen trichloride, nitrogen belongs to group 5, so it shares 3. So 3 of them are bond pair and 1 is a lone pair. And due to the presence of the lone pair, there's more repulsion, and now the molecule, because all the nitrogen is more electronegative, so nitrogen will be partial negative, chlorine partial positive, but overall one side of the molecule, all the particles are there, so it does not have a symmetry. That's why it will be a polar molecule. So for a molecule to be polar or non-polar, for a molecule to be polar or non-polar, it depends on the symmetry. So if it is a symmetrical molecule, it will be a non-polar. If it is not symmetrical, then it will be a polar molecule. The second one, which bond angle is present in a molecule of methanol? So how to identify? So you have to draw the structure and draw the bond pair and lone pairs. So in methanol means 1 carbon, 3 hydrogen, then oxygen with a lone pair, 2 lone pair, and then, so when we check the bond angle, because there are 4 bond pairs are there, and when 4 bond pair and there is no lone pair, so it will be tetrahedral with a bond angle of 109.5. For oxygen, there are 2 bond pair and 2 lone pair. So due to the presence of each bond pair, the bond angle decreased by 2.5. So total 109.5 minus 5, or a bent or a V-shaped structure. So bond angle will be 104.5. So which two angles are present in the molecule? That is 104.5 and 109.5. Is it clear? Question 2. In question 3, this question is about the hydrides of carbon, nitrogen, oxygen, and fluorine. The hydride with the highest boiling point. Basically, the boiling point depends on the intermolecular forces, and intermolecular forces can be hydrogen bond, and that can exist only between hydrogen and bonded with oxygen, fluorine, or nitrogen. Then it depends on dipole forces, and then it will be induced dipole or London dispersion forces. So, but the London dispersion forces increases as the number of electron increases. So which is having the highest boiling point? Water is having the highest boiling point. Why? Because water can form more hydrogen bond per molecule as compared to any other. This one does not have hydrogen bond at all. This can have hydrogen bond. They all can have. Strength of hydrogen bond is strongest in hydrogen fluoride, but because it only form, like each molecule form less hydrogen bond, that's why it will have a low boiling point compared to that of water. And if the state of ammonia is a gas, hydrogen fluoride is a gas, and water is a liquid, so it is obvious that it will have a high boiling point. The hydride that has the strongest hydrogen bond in a pure liquid. So strongest hydrogen bond, that is hydrogen fluoride, because fluorine is more electronegative. As a result, fluorine more electronegative. So electron pair shifted more towards fluorine, and as it shifted more towards fluorine, stronger dipoles are produced because hydrogen bond is formed. When hydrogen form a bond with fluorine, so HF is there, and there is another. So this electron is actually shifted more towards fluorine. So, and this electron pair also shifted more towards fluorine. So hydrogen is attracted towards the lone pair, and this is known as the hydrogen bond. So it is strongest when hydrogen is bonded with fluorine. But because why hydrogen fluoride is having a low boiling point than water? Because the number of the bonds per molecule which are formed in water, hydrogen bond per molecule, are more as compared to hydrogen fluoride. On descending from magnesium to barium, show the trend in ionization of solubility. Ionization means energy needed to remove electron. So as we go down the group from magnesium to barium, the size increases. So as the size increases, it will be easy to, like, difficult to remove electron from magnesium as compared to that of barium. So it will be easy here. So as we go down, the ionization energy decreases. What about solubility? Solubility of hydroxide, nitrate increase only for sulfate. As we go down the group, it decreases. That's why D is the right answer. You have to learn this solubility trend for hydroxides, for nitrates, for sulfates. Sulfates only decreases as we go down, become less soluble, and hydroxide and nitrate, it increases as we go down. A flame test carried out on chloride of group 2, which select the metal that gives the characteristic flame color. So colorless magnesium, because magnesium, it is actually emitting out energy, but that is not in a visible range. That's why we say colorless. Strontium, that is crimson. Pale green or apple green, that is barium. And yellow red, that is calcium. So it matches with D. So you have to learn the flame colors as well for the group. And the reason, they ask a reason why characteristic flame color is there. So answer is, when we supply energy, electron jump to higher shell, and then when it return back, it release a energy equal to difference in the shells, difference between the shell, and give a characteristic color. The S block metal nitrate that decompose on heating to form nitrite. S block, basically sodium and potassium nitrate, they are stable to heat. Sorry, that was carbonate. Here lithium nitrate, because lithium is smaller in size, so it causes more distortion to nitrate ion, and as a result it forms lithium oxide and carbon dioxide. Sodium nitrate forms sodium nitrite plus oxygen. Magnesium nitrate gives magnesium oxide plus nitrogen dioxide plus oxygen. The lithium nitrate gives lithium oxide plus nitrogen dioxide plus oxygen. And calcium nitrate also calcium oxide plus nitrogen dioxide plus oxygen. So which S block means group 2 elements. So all are group 2, which gives nitrite. So that is sodium. Lithium, because smaller in size, cause more distortion, reduce the strength of a nitrite ion, and it can decompose easily. Which statement is correct? So chlorine is pale green gas that dissolve in hexane to form a brown solution. Chlorine is not forming a brown solution in hexane. So that is not the right statement. Chlorine is a pale green gas that dissolves in hexane to form a pale green solution. That is true. And iodine is a brown liquid. Iodine is not a brown liquid, so this statement is totally wrong. And iodine is a gray solid, black or purple solid iodine, not gray, and that dissolve in hexane to give a brown solution. So that is also wrong. It does not give a brown solution. When iodine dissolves, it gives a pink solution. So the correct answer that when chlorine, which is a pale green gas that dissolves to form a pale green solution. The best way to prepare hydrogen iodide from potassium is to add. We want to prepare hydrogen iodide from potassium iodide. So which substance we should add? A hydrochloric acid, nitric acid, sulfuric acid, phosphoric acid. So which one we should add? Because what happened, iodine are good reducing agent. If we use hydrochloric acid or we use nitric acid or we use sulfuric acid, it won't work. Why it won't work? Because when first reaction hydrogen iodide is produced, that hydrogen iodide can react with hydrochloric acid, that can react with nitric acid, that can react with sulfuric acid. But in phosphoric acid, because phosphorus is already having the higher oxidation state, so it cannot change the oxidation, because iodine are good reducing agents here. So C is the right answer, that phosphoric acid we should use. If you use sulfuric acid, like example H2SO4, when it react with potassium iodide, the first, it will produce potassium hydrogen sulfate plus hydrogen iodide. And then this hydrogen iodide will react with sulfuric acid. As a result, what it produces, multiple products are there. It might produce hydrogen sulfide and iodine molecule, or it might produce sulfur dioxide and iodine molecule, or sulfur and iodine molecule. Same thing happened with nitric and hydrochloric, but with the phosphoric acid, iodine are not able to reduce this phosphorus 5, because phosphorus valency is 5, so are not able to reduce that. That's why we prefer to use phosphoric acid. When concentrated sulfuric acid react with solid potassium bromide, sulfuric acid is reduced to, so potassium bromide, so H2SO4 reacted with potassium bromide KBr, it will produce potassium hydrogen sulfate plus hydrogen bromide. And then bromine, what are the products which bromine can produce? So then hydrogen bromide HBr is a redox reaction, reacted with another molecule of sulfuric acid. As a result, it produced sulfur dioxide plus bromine molecule. So when we react with hydrogen chloride, it does not, there is no reduction. But with this, it produced sulfur dioxide, and the other one, if iodide was there, it produced hydrogen sulfide. So each is -2 or -4, so this will be +4. So +6 changed to +4. Here it was, so that is a reduction. So it is reduced to sulfur dioxide. So when hydrogen bromide is there, it does not produce sulfur dioxide. That is why it's wrong. And sulfur is also not formed during this reaction. That's why it is not correct. Then for D, this is not a reduction like sulfur trioxide is formed. So oxidation number of sulfur is +6. Even sulfur trioxide is formed. So that is not reduced as well. The greenhouse gas with the highest mean concentration in the atmosphere. So to be a greenhouse gas, the bond should be polar. So actually that is water, H2O. Carbon dioxide is a greenhouse, water is a greenhouse, methane is greenhouse. So we are not left with any other options are not there. So like either carbon dioxide and water, but percentage of water is more in the atmosphere as compared to percentage of carbon dioxide. And they're asking highest mean average concentration. So percentage of water vapor in the atmosphere is more as compared to molecule of carbon dioxide. Then when potassium chloride dissolve in water, the main interaction between the ions and the water molecule is, so we have potassium iodide. When we dissolve in water, so it will dissociate into K plus and I minus. And you should be able to draw, because the oxygen is, O is partial negative, hydrogen is partial positive. So the oxygen molecules will be closer to potassium ions, the partial negative. So with what interaction we called this as an ion dipole, like interaction between the ion and the dipoles, that's called ion dipole. And in case of iodide, the same thing happened. Hydrogen ions will be attracted because they are partial positive. And it releases the energy which it releases, that is known as hydration energy. So, and this interaction is known as ion dipole, like ions and dipoles are interacting each other. And if the hydration energy is more than the lattice energy, the substance will dissolve. In question 12, what are the properties of liquid 2-chlorobutane? Halogen alkane, remember halogen alkane are insoluble in water, does not dissolve in water. So either A will be answer or B. And then whether it is deviated, because in a chlorobutane, the molecule is a polar. It is a polar molecule. When the molecule is polar, then it is deflected towards the charge rod. So that's why A is the right answer. Then how many organic elimination product form when 2-bromobutane is heated with concentrated solution of potassium hydroxide and ethanol? So basically elimination reaction will occur. So elimination reaction, we have 2-bromobutane. But means 4 carbon, 1, 2, 3, 4. This is CH3, this one is CH, this one is CH2, and this one is CH3. Now what happened? So when the double bond, like because of elimination reaction, it will turn into alkene. How it turn into alkene? Then two possibilities are there. Maybe this hydrogen is removed with the first and bromine will go. So if this hydrogen is removed from the first, so this will be CH2, CH, CH2, and CH3. So it will form but-1-ene. But but-1-ene cannot have an isomer. Like but-1-ene, geometrical isomer will not be there. But what might happen? Maybe the hydrogen is removed from the right hand side, bromine will go, but hydrogen removed from the right hand carbon. So it will produce CH3, CH, double bond CH, and CH3. So this is but-2-ene, and but-2-ene will have geometrical isomer. One will be cis, another one will be trans. So basically this molecule might be a cis, might be trans. So cis and trans, there 1, 2, and then 3. So 3 possibilities are there, like can be formed. That's why for this question, C is the right answer. Which two isomeric alcohols, C4H9OH, expect to give peak due to CH2OH in the mass spectrometer? So if we have butane 1-ol, So butane 1-ol, this will be CH2, OH will be there, CH2, CH2, CH3. So if we break from right hand side, so the first we might get this part only. So yes, so butane 2-ol is giving this peak, that is true. Then 2-methyl propane 1-ol. So 2-methyl propane 1-ol. So 2-methyl propane 1-ol, when we start to break from the right hand side, again, this will give CH2OH peak. So there will be CH2OH peak. So 2-methyl propane. So A is the right answer. Why not 2-methyl propane 2-ol? Like if I draw the structure of 2-methyl, A is the right answer. But why not 2-methyl propane 2-ol? So CH3 is there, OH is there, and then CH3. So there will be a peak at CH3, then there will be a peak at this whole molecule together. So we will not get a peak due to CH2OH because we want a peak of CH2OH, but we won't get from left to right or right to left. That's why 2-methyl propane 2-ol will not give us the peak. So these are the options. Even butane 2-ol does not give the peak because butane 2-ol means the OH is attached with the second carbon. So if we break from right to left or left to right, it won't give CH2OH. This is only possible when OH is attached with the first carbon. That's why A is the right answer. The part of infrared spectrum of a compound is shown. The molecule, the wave numbers which are absorbed, that are also given. We have to identify which compound is this. So we have to use the spectrum here. As you can see, there's a broad range here and there's a sharp. So this broad range if it was an alcohol from 3,700 to 3,200, 3,200 should be there. So 3,007, there's no peak for 3, so it cannot be an alcohol. So means this cannot be an alcohol. For a carboxylic acid, it should be C double bonded with O, and there should be OH. So 3,300 to 2,500. And then for OH should be there. That is the OH of a carboxylic acid. And the C double bonded with O peak. C double bonded O peak for a ketone. And if you see this peak, that is 3,000 to 2,500 to 3,300. So this is 2,100, 2, 3, 4, 5. So this is 2,500. This peak should start from here and it should end here. It should be broad peak. But you can see it is not within that range. So it means it is not carboxylic acid. So either it will be an aldehyde or it will be ketone, because the two options which are left. Then propanol, if it was an aldehyde, 1,740 to 1,600. So this peak, this is 2,000, 1,900, 1,800, and 1,700. So if it was an aldehyde, the peak should be from 1,800 to 1,700. 1,700 to 1,800. So this is from like 1680 to 17. So it is about within the range. So aldehyde or a ketone. So this gives either aldehyde or ketone will be there. Then we have to confirm whether it's an aldehyde. So there should be a peak from 2,900 to 2,800 and 2,775. So there are peaks. So if there are peaks, it confirmed that the presence is, this compound is aldehyde. So propanol is there. Because the CH of a propanol, if aldehyde or a ketone CH are different, they will have different peaks. So that's why it is propanol. So why not carboxylic acid? Because it does not follow the range for the carboxylic. Why not alcohol? That peak is missing. So either aldehyde or ketone is there. And we confirm this aldehyde by checking these peaks are also present. In question 16, two alcohols are oxidized under a mild condition. These alcohols each form a compound that give a red precipitate on heating, either with Benedict or Fehling. These alcohols are, so basically, these alcohols are producing aldehyde. When alcohols are oxidized, at mild condition, they are producing aldehyde. How we confirm it is producing aldehyde? Because it give a positive result with Fehling or Benedict solution. Because aldehyde can give a positive result. So what could be these alcohols? So it should be a primary alcohol, because primary alcohol can oxidize to aldehyde and then aldehyde oxidize to carboxylic acid. So if propane 1-ol is a primary alcohol, but propane 2-ol is a secondary alcohol, so it will produce aldehyde. Propane 1-ol and butane 1-ol, both are primary alcohols. As a result, when they are oxidized, this will produce aldehyde. So B is the right answer. The other options, because 2 is there, propane 2, so they are secondary, and butane 1 and butane 2. So one is primary, another one is secondary. Organic compound which react with sodium but not oxidized. So it can be reacted with sodium, but it cannot be oxidized. So it should be tertiary alcohol cannot be oxidized, or ketone cannot be oxidized. But the second part they mentioned, it is reacting with sodium. So if it is reacting with sodium, either alcohols can react or acid, the carboxylic acid can react. So ketone is totally incorrect in terms of the oxidation. Like ketone cannot be oxidized, as I mentioned, but not oxidized. Ketone can be there, but it does not react with sodium. So alcohol can react with sodium. So it should be a secondary, it should be a tertiary alcohol. So which one of them is a tertiary alcohol? So C is a tertiary alcohol. Primary and secondary alcohol can be oxidized, and they can also react with sodium, but as in the question they mentioned, it does not react with sodium. It react in the question they mentioned it react with sodium but not oxidized. Primary, secondary, and tertiary all react with sodium, but primary and secondary can be oxidized, tertiary cannot be oxidized. In question 18, which statement about the carbon footprint of a fuel is true? Hydrogen has a 0 carbon footprint as it does not produce carbon dioxide. Basically, we don't have a carbon neutral, this is just a theory, but practically we don't have anything which is carbon, 0 carbon emission. Why? Because even though when we burn hydrogen, it does not produce carbon dioxide, but there's also a transportation of a hydrogen. Like we transport the hydrogen from one place to another by using the vehicle, which are using carbon fuel. So there is an emission of a carbon. There's a, like, carbon footprint mean the activity which might alter the percentage of the carbon dioxide in the atmosphere. That's called carbon footprint. So all the fuels have, any kind of fuel which we use will have a carbon footprint. So no fuel has been discovered with a 0 carbon footprint, because when fuel, even though hydrogen is not producing carbon dioxide, but when we transport hydrogen, we are using vehicles which are using a hydrocarbon. and that is not a carbon neutral fuel. So theoretically, we can say carbon neutral, but practically there is no carbon neutral or carbon fuel which is having a zero carbon footprint. Dinitrogen tetroxide and nitrogen dioxide form an equilibrium mixture in a gas range, as you can see. The pressure is rapidly double and the mixture is then allowed to stand. What will be the color? What we'll observe here? If we increase the pressure, equilibrium always shifted towards side where number of moles are less. So the pressure is rapidly double. If we increase the pressure, what will happen? The volume will decrease. When the volume will decrease, so the molecules come closer to each other. First thing what happened, as in the beginning, the molecules are far. One is pale brown, light brown. Another one is a dark brown. So when we increase the pressure, we reduce the volume. So first thing what happened, the particles or the molecules come closer to each other. As the molecules will come closer to each other, what will happen to the intensity of the color? The color intensity increases. As a result, when the color intensity increases, the appearance, it will appear darker. That's why, like example, in winter, you may have seen the smoke which is coming out. It appeared to be dense. Why it appeared to be dense? Because the particles are very close to each other. So when we instantly compress, the particle come closer, so it appeared to be darker. But now increase in pressure where the equilibrium will shift, equilibrium or a balance will shift towards the left-hand side. When the balance shift towards the left-hand side, so this dark brown appear to be paler or lighter in color. So A is the right answer. So in the beginning, it is dark brown. In the beginning, it become darker because the particles come closer to each other. And then due to shifting of the equilibrium, the color will get lighter. Like the number of the particles of nitrogen dioxide, the dark brown, that start to decrease. That's why it appears to be lighter in color. So this was January 2018, Unit 2.